And now it's time for Ag Geek Speak with
GK Technologies,
Sarah and Jodi.
In the fields again, I just can't wait to get in the fields again. The life I love is spreading potash for my friends, and I can't wait to get in the fields again. No, I can't wait to get in the fields again.
Welcome back to Ag Geek Speak. We are so excited for this episode. We have a very special guest, Shawn Kasprick, hailing from the northeast corner of North Dakota. He works for Simplot Grower Solutions. He's had a number of different roles within that company over the years, but we're going to have a great conversation about his career and things that he's done with precision agriculture. A lot of people know Shawn from a lot of different places, but I don't know if people always realize what an impact Shawn has had to precision agriculture in our area, and actually, quite frankly, just to precision agriculture and a discussion. So we're going to talk a little bit today about some of his career and some of the fun things that he's done over the years. So thank you for being here, Shawn.
Well, welcome. Thank you. And I'm glad to be here. It was interesting to be on some of the podcasts. So
that's great. So tell us a little bit about yourself. And I'm going to throw you under the bus a little bit because I know that you were a Walsh County 4-H'er back in the day.
I did a lot of things within ag, of course, within 4-H being one of the group and doing a bunch of things there. So that's kind of where it started, grew up on a farm on the eastern side, right along the river, so it was always something to do with farm. And it was always great to, whenever you got done with schoolwork and you're on the farm, right? I mean, you do whatever you could and it was fun.
That's long story short. I actually knew Shawn through 4-H myself. I was a 4-H'er back in the day too, in the same county. So, yeah, good times.
So you grew up on a farm, and what did you go to college? What was your story after high school?
So of course, coming from the farm, that's what you want to do, right? I mean, the whole plan was to go back to the farm. That's what I wanted to do. That's what I love. I'm always into ag. So I went into school. I went to NDSU, crop and weed sciences. And while I was there, start talking through things, I can actually I think it was 2 more little classes, and I got my soil science degree too. So I did both of them at the same time because I loved both of them, and really they go hand in hand. I mean, anything you do with ag production and crop production, not only do you have the fertilizer side of things, you have the crop care, and so it all went hand in hand.
I didn't realize that you were that close to having a soil science degree. That is pretty fun. But when you think about the major components of agronomy, right, it does start with the soil and the planning for the fertility. And hey, is the soil right for actually putting a tillage tool through it so we can make a seed bed here? And then you move into the whole crop management thing, which really does come down to crop and weed.
Right. And, when you start looking at all the classes that you're supposed to take and you talk with your advisor, these are the ones. And there's always those optional, you could do this or this. Okay, well, I kind of like this. This is what I want to do. And they're like, and then after a while, they said, well, you should go talk to this advisor over here too. That's what I did, and ended up being able to get a degree within the soils department. So that was fun.
That is very fun.
Just collecting degrees,
So that's great. So you graduated from NDSU with a bachelor's in crop and weed science and soil science?
Soil science.
Oh, so you're a double major.
Yeah.
That's very fun.
And then, so then I went to Simplot, and to continue with the career, with the education side of things. That year, it was 2 years after I started within Simplot, Iowa State had started their online degree, their distance education degree. And so I went and applied on that and got my master's in agronomy from Iowa State.
I did not know that you had your master's degree in agronomy either. I feel like I'm really getting to know you here, Shawn.
I feel that I assumed you had a master's. But no, that's really cool. I mean, can I ask what year they started doing that? Because I still have friends now that are doing that in 2025.
Yeah, it was 99 when they started it. I think in 98 they started it for you had to be in Iowa. And I was like, okay, I don't know how I caught word of it or how I ended up finding out about it. But then I did my application and sent it off to them. And I had to get a couple of my professors from NDSU to give me a letter of recommendation to send off to them. And so I got that done. And I was one of the first classes allowed outside of the Iowa state that they brought in. So that was kind of fun to go through that. And
so you're actually one of the first out-of-staters in that one too.
Yes.
That's pretty neat. That's really neat.
So what was that like? So like I've got two questions here. What motivated you to go back and get your master's? Like what part were you looking for with that master's? And then B, what about your class? Like, okay, so 1999, what was a distance education like you didn't have Zoom, right? So like how did you do like an online master's back then?
So what we ended up doing is, I had to go there for orientation. So I had to be on campus for orientation. Throughout the whole time cycle, it was, okay, here are the classes that are available. How much do you want to take on? And at the time there's no kids. It was just me, my wife, and we were just doing the things that we needed to do. And so it was whatever I wanted to take on. So I took on, I think, 2 classes, maybe 3 classes at a time. And I'd come home from work, eat supper, and sit there and open my book, read my book, do my quizzes online, whatever I needed to do. Professors, everything was either email or we would have the forums and the blogs online that we would have to communicate back and forth. And like all of this, we had to communicate so many times. And it was really about getting how many times that we would interact with our professors or the other students. We'd all have to give our input on a specific topic. And then it was just kind of a forum going back and forth. All of the tests that I would have to take for one class or another, I went to the high school and they got them proctored within the high school. Within one of the teachers at high school just said, yeah, if all you need is me to sit in and sign off on your tests that you took them, like, pretty much, and you have to send them in. I can't turn around and send them in for them. So yeah, they agreed to that and got it all done.
That's pretty neat. I had no idea that there was an online distance thing happening at that time.
Yeah, that's amazing. I mean, it sounds like it's very heavy, written communication based.
Yes.
Which probably, you got to solidify your thoughts and write it out and make sure that you understand the concept by writing that out. That's fascinating.
Okay, if it's all right, I want to kind of pause on the education conversation here with the intention of circling our conversation back around to this. I'd like to ask you how things went in your career to kind of where you got to today, and then ask you a question after that, how your education at the beginning really helped you accomplish whatever you wanted to in your career, or how that all works. So how's that for a fully loaded baggage question?
Wow.
Yeah,
Let's just
right?
dive right in.
Let's just dive right in. I'm kind of famous for that. But yeah, why don't you tell us a little bit about your career and the things that you did within Simplot? Because you were kind of one of the first people really working with precision agriculture and kind of one of the people that really drove Simplot's precision agriculture program.
Yeah, so it was an interesting start to it all because like I was brought on board within Simplot the first year more or less as a crop advisor trainee, right? I was supposed to be trained in, I was going to be one of the salesmen, and I think that first year of doing it, like I loved computers. I always dealt with computers all the time anyway, and at about that same time, Simplot was looking for getting into precision ag, and what do they do? And they're like, oh, you like computers? Here's a computer. You're going to do precision ag.
Good luck.
Okay, where do we start? And so it really kind of started that way. I mean, it was pretty much, throw us a laptop, you start precision ag. Here's our kind of group and the people that we currently have involved, and start off.
So for frame of reference, approximately what year are we talking here?
97.
97. Okay. So GPSs are barely on tractors at this point in time.
Okay. So GPS was on some of the equipment. It was all, you had to pay the subscription fee to get that unlock code in order to be able to have some reasonable accuracy, and it isn't the accuracy that we have today at sub meter or sub centimeter accuracy. It was, well, you're within 3 feet or 3 meters of it. You'll be good. For fertility, probably is just fine. But when you're dealing with anything smaller than that, there was absolutely no way we could do it.
And I think it's important for the audience to note that, you spent most of your career in Northeast North Dakota.
Yes.
And most of the crops up there are sugar beets, potatoes. There's a lot of high value row crops where that accuracy on the GPS does matter.
Absolutely, it does. Yeah. Yeah. So, taking all of that in, everything that we were doing at that time was, just building fertilizer maps and recommendations. So I think the mid to late 90s, everything was looking at grid sampling, right? Everything was grid sampling. And, I think a few things just started off with, let's look at zones. Let's look at, satellite imagery, and look what we can do. Here's areas of higher growth and lower growth and everything in between, and let's make zones off of that. I mean, looking at the maps, it makes some sense, and let's start that way. So that's kind of what we were looking at and trying to bring all that in from one computer system to another and have everything talk properly, became a big issue because, not everything, our system is our own and nobody wants to talk outside to that system because that's different, and you're like, really, this is the system I'm got. What is your data set on the backside? And so it's understanding how the data talks to each other, and that's what it is.
I always think it's interesting, and I always equate it back to hydraulic hookups. We've got the whole world, and then we had John Deere hookups. And I don't think a lot of people in today's world realize what an issue getting data to talk across platforms is. It's really nice when we've got standardized hydraulic hookups. It's really nice when all the data talks. The farmer really does benefit from that. I can honestly say I believe that farmers appreciate that a lot.
Yeah, and I dealt with those adapters for the hydraulic hookups. We had some of those changeovers, so I get exactly what you're talking about.
It's a good metaphor, isn't it?
Yeah, absolutely it is.
And I have to plug in ADMS at this moment because that's one of the things we really pride ourselves on is that, okay, we can bring in a lot of data, as long as it's not a proprietary thing that's locked to us. But for the most part, we can read so much of that data and also export it in a way that will get to where you need to go. I mean, that's so important to us in long term. I mean, we've been around for a long time and we plan to be here so that no matter what, you can have that data and use it, no matter how precision ag progresses and changes over time.
Yeah, and everybody had to get there at some point is you have to understand the background of data and how it actually handles and how it talks. I mean, we see our displays today and we see our displays, on any of the computers and you're like, oh, that's a pretty picture. But unless you understand the data in the background and what it took to get from point A to point B, you can never move that on to the next level unless you start to understand that. And I had to go through that and that growing pain myself. So it's just something you deal with,
And so to just put things in a frame of reference here at this time, when you're working, just trying to figure out what to do with this computer that Simplot gave you and how to get data to talk, you're really in the process of developing what Simplot uses for their precision agriculture software platform. Is that correct?
Yes.
So you pretty much are responsible for developing that.
Yeah. So within our groups, we had some groups talking with each other. Some of the groups dealt with the Ag Leaders SMS software and some of that stuff going on. We had, us where we were dealing with the soil tech and what soil tech had to bring at the time. And even within our own group internally, we were dealing with ArcView for all of our GIS stuff on the backside. And that's kind of where, we're already in ArcView and this is what we're going to do. And so that's kind of what we just kind of transitioned ourselves into ArcView. And that's what we were running in on the backside.
Okay. And along this time, you must have had some pretty big conversations with Darren because he was programming software at the same time, or at least I know that you guys have had conversations along the way.
Yes, we've had conversations along the way, and at the time in his previous life, in the previous career that he had, there was a lot of discussions back then, and it really, at that time, it didn't fit what I was looking for, what I wanted to do. Although we were kind of all tracking the same direction, it was just not. The mindset that I had and what I wanted to do and where I wanted to go was not exactly the same thing. So we had conversations and
had the opportunity to learn from each other and
Yep.
get ideas. And that, I think that's something that's really important to remember is in the late 90s, there's a lot of pioneers of precision agriculture out there that were really working hard to try to develop systems that worked well for handling lots of different data. And there's a lot of people that had a lot of different ideas. And it's always so neat to me how we had these great collaborations. We can have different ideas. And quite frankly, the precision agriculture industry that we have today stands on the legs of those conversations and collaborations. We've got different opportunities out there to work with different things. And it really has made precision agriculture feasible in today's world to actually be something that works for farmers, for applicators at the field level.
Yes. And I mean, it was, when everything was coming out, it was all, you either had to do grid sampling and they have a place that's just because it is an absolute, here's a soil test within this little geography, whether it be when we started at 4 or 4.4 acre grids or 2.5 acre grids that they're kind of been moved to, or you take a look at the zone map and you assume everything within that same zone is all the same within the soil samples in the soil test. You either take an absolute within the grid, that small little grid represents that part of the field, or you move it to a larger scale. And it just made more sense to me, not only economically, but this area is all the same. Why do I want to subdivide it any farther? That's kind of where I was looking at it.
And with that too, right? Like nitrogen is such an important part for us in North Dakota. So doing grid samples across big fields just is hard to do every single year. Whereas with a zone, you can take less samples and still get that nitrate number every single year. Like that's hard to, how do you do grid sampling to 24 inches every year when you got to get that nitrate number?
Right.
It's just not feasible.
Well, and if you look at where it started from, back in the kind of the I states in the Corn Belt where they were doing a lot more of the grid samples, they don't have the field sizes that we do necessarily. I mean, they do have some large fields, but theirs is cut up a little bit differently. They have some rolling topography that we don't necessarily have, at least here in the valley. And at first when they were looking at it, it was all on pH and lime.
Yes.
They were doing a lot of variable rate lime and those applications, which on a grid sample, that makes sense. When we start getting into things that we're doing here, it just didn't quite fit the same way. And so, the direction that we went with zones makes more sense.
And you also have to remember that, especially in the area, the geography specifically, in the Red River Valley area of North Dakota, we have a lot of sugar beets, and we're actually soil sampling down to 4 feet for those because we need to know that nitrogen number to keep the quality of the sugar beets. So imagine doing grid sampling down to 4 feet. Ufta Meda, says the Norwegian.
And we were doing that, when we first started, there's still people, that's their mindset is, okay, I'm doing grid samples because that's variable rate to me or to in their what they were looking at. And they were pulling samples to, the 0 to our standard 0 to 6, 6 to 24, 24 to 48 inch samples. And we were going there. And, some of that also ended up developing into what Franson had dealt with for our sugar beets is taking that nitrogen credit. And he was doing a lot of work up there. He was actually looking at how deep does our nitrogen go because we're having to deal with that. Do you ever remember that we were dealing with 6-foot samples?
No, I do not. Oh my gosh, that would be terrible.
Yep.
I want to see the probes for that.
So there was, and of course, all the problems that you have when you start going too deep and you don't have the probe or the telescoping probe, you have to, if dirt falls in, well, that hole's screwed and you have to go to another one, So they were doing that for a few samples. They were doing it. It was a lot of it. It was just more research and just starting to develop it into the field. And we're kind of playing around with that. And at the end of the day, it was like, you know what? We don't care. It was just too much work. It was just a lot of things going on. And
you can glean what's going on with the deep nitrogen from those 4-footers. You really can.
Yeah.
Gosh, those 4-footers are enough work. Oh my gosh.
Well, and if you think about it, when we're dealing with, what do sugar beets do well?
Scavenge.
They go down super deep and scavenge all of that nitrogen and that we're worried about and bring it right up to the top for us. So fine, we'll deal with that. And that's how we ended up kind of continuing on with that is that deep nitrogen discussion. We can see it in the sugar beet tops and the sugar beet leaves and go from there.
I remember John Lee talking about that at AgVise. Is like after the nitrogen recommendations were updated, there was a couple years where there was still some issues with that really deep nitrogen. But after like the updated guidelines and years of where the nitrogen rates weren't so heavy, finally we got to levels where the nitrogen was normalized and we could rely on that 4-foot depth, and we didn't have to worry about any of that really, really deep nitrogen.
Right. And I know one of our customers was doing a soil pit. Every year he was doing a soil pit. Just some of it was for his own amusement and his own knowledge of what he wanted to do. But the university, NDSU, had some test plots up there for some other things and other reasons, and they would kind of take advantage and go up there and say, "Oh, here's a soil pit. Let's go look at it." And you climb down into that soil pit, and I think it was I can't remember if it was only a 6-foot or if it was an 8-foot soil pit that he had dug out. Climbed down the ladder, and it was up against sugar beet. So you see the profile of the sugar beet down there.
Wow.
And I think at 4 to 6, it was during the drought in 06. And
so I bet they went really deep then.
at 6 foot, it was still a pencil thick.
Jeez.
So,
that's amazing.
So all of that nitrate is being pulled up and anything else. And so there's some other stories of what else is down that deep profile too. Anything that leaches, herbicides included, can be pulled up and show up as an issue in the crop. So
yes, that can always be very fun.
yes.
Let's see what the leaves look like.
It
Right.
sounds like you've seen some things.
Well, there's that, and then you try and diagnose what happened here, and you're like, I have no idea. I mean, what this looks like, it hasn't been applied in 10 years. Well, yeah, that's how you kind of figure that stuff out. It scavenged down and it just brought it all the way to the top.
It's interesting because I have another precision agriculture client that actually is doing variable rate residual herbicides to try to make sure that, especially across landscapes that are really changing with soil texture and organic matter and pH, we're getting the right activity in the right place, but we're getting not too much activity in the wrong place.
Right. Exactly. And you look at some of those, and I know we had that conversation, Jodi, the other day, but you look at some of those soil or the soil applied herbicides, you look at the labels on them, and like the dual label on there, it says a low, medium, and high soil texture, or low, medium, and high organic matter. These are the rates that you should apply. Well, it just screams variable rate.
Absolutely.
Yep.
It does. Absolutely. Yes.
Yep. And I think like in the worlds of weeds, right? Like weed control in general has just been so effective that it's like, oh, we don't really have to pay attention to that. But now as we are dealing with herbicide resistance weeds, I mean, it's okay. Now we're looking at those labels and thinking, how do I maximize this so that I'm getting the absolute optimum control with the tools that I still have in my toolbox?
Without killing the crop in the and other places where I got to back that rate off.
Right. Yeah, absolutely.
So okay. So you got this computer. You're working on developing how data is going between platforms. You're creating the platform that Simplot is using. You were pretty much in ARC at that point in time, trying to make all of everything go. Are you guys still using ARC? Do you have your own platform now? How's that going?
Yeah, so we're all still working within ARC. That is the background engine that runs everything that we're doing. Everything that we started with, and of course, once you start in within ARC, it's its own coding platform, and they've now moved to Python coding, and so that made it a whole lot easier. But so in the background, not only did I do all this stuff for school, but I also learned how to program and things on the backside because you
were bored and you needed something else to do.
Right? Yes, that's absolutely it.
Jeepers creepers. Okay, so you learned how to code. So you're a computer coder now. That's amazing.
And like I said, I loved computers and I've always known computers, so it wasn't that big of a deal. It was just like, okay, I got to figure this out, and we'll go in there and start coding and make it work. And so that's kind of how this all developed.
When you were starting out, tell us a little bit about the field applicability of it and some of the experiences that you had early on getting it to actually work.
So everything that I've always done always comes from a place, of course, from my background is soils and agronomy. And so everything that I've dealt with all the time always starts with agronomy. And, so, when we first started into this and everybody had these Their software and proprietary, they're like, oh no, ours is special. Ours is this, you can't, nobody else can do this. I'm like, it's agronomy. It's agriculture. It's not like we're holding secret codes for the nuclear, any nuclear things going on. Come on now.
It's a lamb's quarter in the field.
Right. Yeah. And this is sand, silt, and clay. We're not in organic matter. We're not dealing with a whole lot, So it's agronomy on the backside. That's all it is. That's how we start with it. And what makes sense when we start looking at it? Yes, the satellite imagery made sense. This area was, high, medium, and low for within the reflection of the satellite imagery. But now you start if that's all the zones that you're doing, and you start making there, you have to also answer to the customers. You answer to the growers. Okay, why is that area green? Okay, or why is this area poor growing? So you have to start looking at the background, and we were doing a lot of things starting with topography mapping, right? I mean, topography mapping started really big. We were running up and down the fields with RTK level instrumentation and versus LiDAR that we have now, or, where the customers can pull that data off on their own RTK systems. We had to do that ourselves at the time. So we were pulling all this in, and we could see that within the elevation mapping. And sometimes that elevation mapping matched exactly what we were dealing with the satellite imagery, so it was really good. You start looking at some of the old books on the soils books, and on the backside, they had old satellite imagery. I mean, besides the soils data, they had old aerial imagery that you started looking at. And some of those old aerials started pulling up. You could see old farmsteads that used to be in there that are no longer there. Okay. And I know you start looking at that, you're like, oh, well, that explains why this area is so much different. There used to be an old yard in there. You start talking to the customer, and he's like, you know what? I don't remember that, but his dad does.
Yep.
And like, oh, okay. So you start looking at these things, and now, you start adding all of that together, and you start pulling in multiple layers into there. And that's where we're dealing with it. We're always pulling in multiple layers, looking at more than one layer. Because if you only deal with one layer, can you explain everything that's going on with those zones or within that satellite imagery or yield map or whatever based on one layer?
So that's an interesting component to think about, and actually something where your system is quite similar to ADMS. Because again, I would say that's we have that conversation all the time. How do you go and pick out that one image that describes your field all the time? Does that image actually exist? No, it always has to be a combination of multiple layers. And even there, once you have that in and you might be describing that area, you still might need to do a little bit of modification within that picture so that you really get what you want.
Right. But you look at the time when we were first starting with this, a lot of our competitors out there, a lot of people that were doing different things who were just looking at that one satellite imagery and saying, okay, this is how we're going to zone your field. Okay, that's great. So that was the last time it had sugar beets, which happened to be, because it had changed hands or whatever, was 5 years ago. So the field this coming year is exactly the same as it was 5 years ago? Probably not. There may be some similarities, but there's a lot of things that have changed since then.
Absolutely. And what I think is so interesting about that is there's a lot of companies today, especially new companies trying to enter precision agriculture, that do just that. They find that one image and they say, this is going to be the image that's going to be your zones forever. And we've come so far in precision agriculture. I mean, it didn't work back then at the beginning. Why would it work today?
No, and that's just it. They want to find that one thing and just, this works. Like
the easy button.
The easy button, absolutely.
When you think about it, it's agriculture. We're working with a natural system. It's complex. So like when you think about it, it just makes sense that there's more than one variable going on that's explaining why our crops are looking like they are.
Right.
So how do you bring in those multiple layers to help you get to a somewhat predictive map that you can fertilize off of or make decisions and make management choices off of and select and not select and apply and not apply in areas.
Right. And that was one of the nice things when we were dealing with ARC. ARC has done that in the past. The whole background for ARC is all of the full-blown GIS. Our little agricultural portion that we wanted to play around with was just this little teeny tiny scope of what ArcView can do as a total. And so they're like, yeah, we can pull in that data set. Not a big deal. This is what we do. And so pulling in imagery for ARC was not a big deal. Pulling in other data sets for ARC, they've done it on the backside for what the other applications. So it wasn't that big of a deal. We just had to make it work for what we need to do in ag. So you start pulling in multiple layers, and you got to be careful because you pull in too many data layers and it gets way too complex. So how do you simplify it? So it really comes down to what layer or a couple of layers, it will explain everything that I need for this field to continue and move on.
But that brings in the human portion of it, right? Where an agronomist is looking at these pictures of the field with their background and knowledge in crop production and soils, and they're able to look at images and be like, yes, this is a layer that should be included. No, this is not a layer that should be included. And then you could put it together into something that makes sense.
Yeah, absolutely. And there is and that really becomes more of an art form, right? I mean, all three of us could sit down with the same data sets, pull in all of the information, and our zones will come out, I would suspect, pretty close. But the exact line of where I divided it and you divided it and you divided it are all just a little bit different. And that's fine. That's, even when you're making the application, that machine does not stop dead on that line and transition from this rate to this rate. There has to be that zone where it ramps up or ramps down. And so there's that little bit of a variance within that line. So
that works. But that is so true. And we do that all the time here where, we might have different ways of making it happen, but we're going to get to pretty darn similar results. But there's always more than one way to skin a cat. The other thing that I think is so interesting in this conversation, so Shawn deals in a completely different software package, obviously, that he developed. And we here at GK Technology deal with ADMS, but we have that GIS background that, they're both GIS-based softwares, which is very interesting. And some of the stuff within the softwares might be different, but it's got that GIS background. And so, when you're working with precision agriculture, I just think it's really important for people to understand the value of understanding basics of GIS so that you know how to actually operate some of the things. That's not something that's necessarily an agronomic education component, but it's so critical to precision agriculture.
Right. Yeah, absolutely it is.
We've talked a lot about your early career and how you were working on developing software. Next time we'll visit with you a little bit more about, what you're doing with precision agriculture, maybe a little bit about like the in the field practicality of making everything work, and some future ideas. But at the beginning of this podcast, you talked about your education and, how you really pursued that. So can you tell me, how has your education prepared you or enhanced your career? And what sorts, you did most of your education at the very beginning of your career. So how has that really impacted who you are today?
Well, you start looking at everything that you do within schooling. That is actually the preparation for everything that you need, that you want to learn. And so everything that I do within my precision ag, within my career, that's my grounding, right? That's my ground for looking at every application that's out there, because there's all kinds of new tools, new concepts, new products that come out there, and this is the latest and greatest. But let's look at the background. Let's ground ourselves to, okay, how does that application or how does that product actually work in the ground? And so whether it be precision ag and variable rate, a new product that comes out, a new idea, new concept, new satellite imagery that they've got the latest and greatest, let's all bring it back to, okay, does it have applicability in the field level? What is it going to do for us moving forward? And does it actually give me any information that I need to make a better decision than what I had before?
Does it actually work from a practical standpoint?
Yes.
Yep. That's great. It's really fun to hear. People have different reasons for pursuing the education pathways that they do. And so it's really fun to glean that information. And I think for some of our younger listeners, it's always great to have that information in the back of their minds as they're going through their career and making decisions. So I appreciate that. That was a great first conversation here with Shawn. We've got so much more to talk about. We are going to have an additional episode next time with Shawn from Simplot. We appreciate that. And with that, at GK Technology,
We have a map
and an app for that.
Can't wait to get in the fields again. No, I can't wait to get in the fields again.
Let the geeks at GK Technology help you with your agricultural data. Their agronomists know agriculture. When it comes to creating soils and zone maps to maximize yields in your fields, you can trust the people with decades of experience in site-specific agriculture. Everyone at GK Technology has a background in agriculture, so they know what makes a farm run, and they speak your language. The geeks at GK Technology have a map and an app for that.